Okay, so we've made it to the last section of the statistics part of the A-level, which is excellent. And this last bit is still to do with the normal distribution, and this time it's about sample mean and hypothesis testing. So what's this about? So we can test a hypothesis about the mean of a normal distribution, the mu. We can test a hypothesis about that, whether we think it's changed, increased, decreased, by looking at the mean of a sample. So rather than looking at the whole population, if we've got some information about a sample, we can use that to test whether we think the mean has been affected in some way. So this is what we're going to do. So if X is normally distributed with mean mu, standard deviation sigma, so variance sigma squared, then the sample mean X bar will also be normally distributed, and this will be distributed as follows. So the sample mean this time, X bar, is distributed normally. It has the same mean as the population, but its variance, its standard deviation squared, is now divided by n, where n is the sample size. And this is something that we just need to learn, that when we're looking at the mean of a sample, this is how it's normally distributed if the population is distributed in this way. Okay, so that's our first learning point for today. When we do this then, basically it's about if you took lots of different random samples of size n, then their means would be normally distributed in this way. So that's where this data comes from. Okay. What we're going to do then, we're going to have a look at a question on this, and we're going to do quite a hard question from the review exercise to have a look at this. One of the things I would say though, and one of the things again that's a really common error, is that this, don't forget, is the variance. So when we're looking at our standard deviation, it needs to be the square root of all of that we're putting into our calculator. But we'll come back to that in a second. Okay, so let's look at a question on this. So this question is, let me just get that in screen. This question is taken from the review exercise. It's actually number 19 from the review exercise on page 69, if you want to know the reference. We'll have a little read of this. It's a past paper question. It's worth 4 marks. There's quite a bit of work to do for the 4 marks, and we're going to look at a couple of different methods. Okay, so the time taken in minutes for Robert to complete a puzzle in his morning newspaper each day is normally distributed with mean 18 and standard deviation 3. So let's just write something down about that. So X, my random variable, continuous random variable, is going to be the time in minutes that it takes to complete a puzzle. Okay, so there's my random variable, and that, we're told, normally distributed with mean 18 and standard deviation 3. So the variance is 3 squared. Okay. After taking a holiday, so he has a break from doing this, or maybe he does it when he does a lot of puzzles on holiday, I don't know. But after taking a holiday, Robert records the time taken to complete a random sample of 15 puzzles, and he finds this mean time 16.5. Okay, so let's have a little think about that. So what's this telling us? It's telling us that the sample size, n, is 15. And what does he find? He finds that his mean from that sample size, so not from the population now, from this sample, his mean of this sample what does he find? He finds that that is now 16.5 minutes. Okay, so again, there's just our bits of information written down. You assume that holiday has not changed the standard deviation of time, so the 3 squared isn't changing. We're just looking at whether the mean has changed or not to complete the puzzle. So what we're going to look at, this mean now, the sample mean, from those notes that we just wrote down a second ago, the sample mean, X bar, is going to be normally distributed 18, because the mean doesn't change, and then our variance, 3 squared divided by n. If you remember, just from those notes before, this is our distribution of our mean, sample mean. So that's what's happening there, and I'm just going to make a little note underneath here that this is mu and sigma squared for this sample mean distribution. So don't forget, when we're doing some working out with this, that the sigma that we need to use, the standard deviation, is going to be the square root of all of that. So just, sometimes it's quite handy to make a note of that. Okay, and what we're doing, we're going to test here State your hypothesis clearly. So H1, H0, we're going to look at test at the 5% level of significance, whether or not there's been a reduction, so a one-tail test here, in the mean time taken to complete the puzzle. So has his mean time reduced after this holiday? So that's what we're going to be testing. Okay, so test whether there's been a reduction in the meantime. Okay, so it's quite a wordy question, but we've pulled out some important information here. We can see that it's going to be a one-tail test as well here because it's a reduction. It's not just a change, it's a less than. Okay, so let's have a look at setting out our hypothesis test. So what's our null hypothesis? Our null hypothesis is that the mean hasn't changed at all, that's staying as 18. Our alternative hypothesis now is that actually the mean's reduced. There's been a reduction, so it's now less than 18. Okay, I'm going to get a clean sheet of paper in a second, but what we're going to do, we're going to look at two different methods for doing this. And we've done this before with hypothesis testing. So we're going to look at two different methods. First of all, we're going to have a look at finding the probability that that mean is less than or equal to 16.5. So we're going to use this normal distribution to see what would the probability of that be, and to have a look at the likelihood of that. Would it be likely to happen under just the normal distribution in the first instance, or has something changed? And then the second way that we're going to do it, we're going to have a look at finding the critical region and then see whether our 16.5 here, see whether this is within the critical region, and then they give us evidence to reject H0 and to accept H1, that there has been a change. So they're the two different methods that we're going to use. Okay, I'm just going to get a clean sheet of paper. So method 1 was to have a look at the probability that that mean value is less than or equal to 16.5. Let's not forget from our other sheets of paper there that the mean is normally distributed 18 and then 3 squared over 15 for our standard deviation squared for our variance. So let's get our calculators out. Let's have a look at this. So we're going for our normal CD, because it's less than or equal to, so our normal CD there. Our lower value, I'm just going to put in an really low value, doesn't matter, as long as it's less than 5 standard deviations. There's 5 lots of the square root of this, less than 18, we're okay, but to be safe, let's just put a really negative value in. Our upper limit is 16.5, because that's what I'm looking for. Our standard deviation is now the square root of this, so let's have a look at doing that. Square root of 9 over 15. And then my mean is 18. And there's my probability, so 0.026403, etc. So what's that? That's about 2.6%. So definitely less than 5%. And the question asked us to test at the 5% level of significance. So the probability of this happening in the normal course of things, it's not very likely at all. It's less than our level of significance. So what does that mean? That means that we've got evidence at the 5% level of significance. What have we got evidence for then? So we've got evidence to reject H0, because this isn't likely to have happened in the normal course of things with just the null hypothesis as it was. And we accept, or there's evidence to support anyway, the acceptance of H1. And what we should always do now is try and write something in the context of question. So what are we going to say here? We're going to say here, there's evidence to support the fact that there's been a reduction in the mean time. Okay, so there's evidence to say now his average mean time is less than 18 and he's improved his times there. Okay, and you don't have to write those exact words, but something like that. Okay, the second way of doing this question then was to look at critical region and then to see whether 16.5 is in that critical region. So critical region, it's a less than, so I'm looking for some value C1, so that basically down here then the probability of being less than or equal to C1 is less than 5%. That's my critical region. So what do I want? I want the probability that x bar is less than or equal to some value here, C1. Don't forget with continuous, less than or equal to is the same thing. And I want that to be less than 0.05%. Now here, because it's a continuous random variable rather than discrete. When we do the discrete ones of these with binomial, you're looking for a value and you might get a value here, or you might get a value here, and it says take the one that's nearest or something like that. But here, this is continuous, so we can actually find this exact value of C1. So what do I mean by that? I mean we can actually find the value of C1 so that that is bang on the 5% cut-off point, okay? Because this is continuous, so there is definitely a value there now, whereas with discrete, there was just values either side of it. So let's have a look at this. This is now going to be our inverse normal function. So we're looking at our normal distribution. We want the value C1, where this is going to be our 5%. So that's what I'm doing with my inverse normal. So let's have a look at doing this. So I want my inverse normal. My area is my 5%, so 0.05. My standard deviation is the same as this, to the square root of here. I think that's still in, but let's just check. So my standard deviation, 9/15, square root of 9/15 even. The mean is 18. And there's my critical value. So C1 is 16.725, etc. Okay, so that's my critical value. That's my value here. And now look, 16.5, the value that I'm looking at, the actual time of his sample, my 16.5 is definitely in this critical region. It's only just in, but it's definitely in there. So it's in here. So 16.5 is in the critical region. Therefore, and then I'm not going to write it out again, but it's this sort of statement again about you've got evidence at the 5% level of significance to accept that there's been a change. Reject H0, accept H1, write something in the context of the question. Okay, that's that question done. I'm going to set some on Firefly for you to have a go at, and that basically is statistics finished. Well done, everyone.